Greetings. Today I'm going to do a video having a look at configuring the gauge, which we saw in the last video briefly. This time I'm going to run it through just a quick configuration to show you how it works and sort of things you can do. Alright, let's turn the backlight on. There we go. Now, what we're going to do is open PuTTY. This one happens to be on COM7, so we'll open that. Drag it back to the right window, and we'll see the monitor. You should see it go into config mode, which you can see, and over here we'll hit R to refresh. So we've got the menu up. Let's have a look at the configuration parameters. So I just hit C. Now you'll see there's lots of bits here. There's up and down buttons for all the functions. The shifted up and down will step 10 units at a time rather than 1 unit at a time. Now let's just have a quick run through. So first one, save the updated values to EEPROM. Q, go back to the root menu. R, refresh, redraw to the display. This is just all done as an ANSI terminal, so you can use PuTTY or whatever terminal you like, as long as it supports ANSI codes. All over the serial interface, so it's a pseudo GUI. Right, the next one down with the exclamation mark 1 is profiles. There are 4 profiles, so there are 4 complete meter settings you can have. That's all the display configuration, gauge, range, all of that. 4 complete sets stored in the meter if you're going to move them between bikes. When you get it, it'll have 4 default sets. I'm thinking maybe CX, VF, CB, and something else at this stage. So in order to change those, as you can see, it's 1 and 2 or shifted 1 and 2. So if I go 1, it's down, go 2, up, 3, and the parameters on the screen will update as you go. Now, when you save it, whatever number parameter the profile is selected will be the default when it powers on. So you don't have to use 0, it stores which one's your preferred default thing. Okay, next one, the speedo mode. Do we want the needle driven by speedo or tacho? So in this case it's a tacho, so we should set it to false. But if you have a look, L sets it to true, so speedo, false, tacho. Units, metric or imperial, so really only used for the odometer and trip meters. Everything's calculated internally in metric, and it just gets converted to miles if you need. Wheel circumference, so if I do W, we go down by 1 at a time. If I do a shifted W, we go 10 at a time. If I do E, which is the up, we go up 10 for shifted, up by 1. Now, oops, overshot, so we'll go down. For this case, it's 470 millimeters of distance for 1 pulse. So that's what you just need to know. If you've got a hall sensor on the wheel and it's a complete circuit, it's going to be about 1.8 meters or so, depending on your wheel circumference. If you've got multiple magnets, then it'll be less than that. Tacho divide ratio, which is T and Y, so up and down. You can go to 4, that's 1 pulse every 4 revolutions. Normally, wasted spark system, you get a pulse every revolution. Sometimes if your timing comes off the cam, that'll be a 0.5, because you'll get a pulse every rotation of the camshaft, which is 2 rotations of the crankshaft. Odometer, 0 and P. This allows you to set the default odometer value in thousands of kilometers, so to the nearest 1,000 when you first install the gauge. From then you can't change it. It will be stored for each of the profiles. You can't change it, but you can change it. So by default it's stored in increments and it's not changed. However, if you do have to reset it, there's a sequence that you do that will allow you to reset it. So it's in there, but it's just not quite so easy to get to. Now, displays. We've got 4 display sets in each of the 4 profiles. So in a profile, you've got 4 settings that you can sequence through. When you push the button, it goes to the next display set. So you've got 4 combinations. So if I use the arrows, it's 1, 2, 3, 4. 0, 1, 2, 3. So you can see the different displays that are set in here. So let's go to in this case, the default power up one is 0. So you set that to whatever you want when you power it up, and then you can cycle through the others. So profile is 2 buttons we can set. If you see the top display select and the bottom display select. So currently it's set to temperature and fuel as a dual display. If I go volts, you'll see volts and the N for gear, clock, pressure meter, fuel meter, temperature meter, trip meter, odometer. That's the first one, so we'll go the other way. Volts, temperature and fuel, temperature and pressure, fuel and pressure, speed. Now that says speedo, but when it's in use it will actually report it in kilometers an hour or miles per hour. And RPM, same. Says tacho, will report the numerical value of the RPM. Alright. So we can also change the bottom display to match any of the same types. So as this is a tacho, I would have normally temperature at the top. Actually, my preference for this bike is, if we go, I have temperature and fuel on the top and actually the clock on the bottom. However, for the next display, my temperature and fuel, then I have temperature and clock. So I've got 2 the same. So let's change this one to be, what do I want? I don't have a pressure meter fitted on the bike, so we'll go to fuel and temp, just the other way up. So one way, other way. Right. So when we're happy with that, we can save. Okay. Now moving down, you can see these are the gear ratios, which are RPM divided by kilometers per hour. So you can set those same way. Hey, there are single steps and 10 steps. Last one is the voltage calibration. This is the divide ratio times the voltage, so it allows you to fine tune the actual voltage measured. Let me see if I put a voltage display up. Let's just go. There we go. It's telling us we've got 14.1 volts at the moment. So this will show you how you can do something live. We're doing it on a workbench here, but when you've got it on the bike, you can do the same thing. So let's step it up. We'll go again 10s. As you can see, as I ramp the calibration up, the voltage red goes up. So in this case, we've got 14.0 volts applied, and we can, that looks pretty good. So that's a calibration there. Alright, I saved, hit the S. Alright, now we're going to quit. And let's have a look. We'll go into the parameter setting. This is where it gets really interesting for you. Parameters. So, for each of the speedo, tacho, temperature, fuel, and pressure measurement quantities, we've got the input for the ADC, the maximum, some breakpoints, the output, and the filter type. Now, we'll go into edit mode. If you have a look up, we hit E, and the device we're on is selected. So it's showing up in red, and you can see the gauge has actually gone to speedo to indicate. So we've got some cursor keys that it says G, H, Y, B, left, right, down in the center of the keyboard. So we'll move across. You can see we move. So we'll have a look. If we go to the input min, this is really the angle which says where the needle, and you can't change that. That one's going to be locked on 0 because that's the basis of what we use. So we go across to the output side, and we can change that. Hang on. But you won't see anything here. Let me go down. I think we're on 245, weren't we? Alright. Put it back onto it. Because this is set as a tacho, it's going to do the tacho one rather than the speedo one. So we go down a line, and right, there we go. Now you can see it has spun around live to show you what the setting is. So if we step it down, that was up, we go down, you can see it moving the needle. So what we would normally do is you go up to set the maximum. That looks about right, right? So you set the maximum, and the minimum is 0 anyway. You have to tell it, here it is 11,000 RPM, tell it what the maximum RPM are, as that corresponds to the angle you just set, the maximum dial, so it knows. Really that's it, but now you can see on the gauge that there's a little, the first divisions aren't even, so we need to do a little compensation for that. So we move across, and this is where you have to do the smallest bit of maths. You have to work out of the 11,000 RPM what that first division is. In this case, it's 4.5%. So yeah, 11,000 divided by 500 comes out as 4.5%. So then we can go to the Y value for this, and we can adjust it so that it lines up on that tick. Alright, and then we go to the second point, which is going to be the 9%, which corresponds to 1,000 RPM, and adjust that to match. And then that's it. That's the gauge calibrated to the faceplate that's in there, because the rest of it's all linear. Really, there's not much more to say. That's how simple it is. Alright, we'll go now down to the temperature, and you'll see the display has changed to the temperature, and it's showing the current value as 757, which is what's coming in. Now, I don't think my input's connected. Hang on. Let me just connect up one of these. Right, there we go. So now I have put it on what would typically be the minimum setting for a resistive value, which is 10 ohms, right? So you've got to thermistor on your bike, and it outputs a certain voltage as has a certain resistance as the temperature varies. So in this case we go, oh, that's set to maximum temperature, and the ADC is telling us that it's 72. So we would come over here and go to temperature and go to the maximum temperature. Now you can either do it the gauge one way round, and in this case the temperature decreases, the resistance decreases as the temperature increases. So the output, if you have a look on that line, let me move across, is from 0 to 100%. Let's just change the type to raw, so we don't have any averaging while I do this. Go up. Okay. Alright, now go back. So the input is 72 at maximum temperature, so we go down. Sorry, hit the wrong key and saved it. Alright, we'll go down to 72. Alright, so that's indicating high temperature. Now, if our temperature sensor was up the other end and we were saying it was 100 ohms, and we wanted that to be our cold point, we go, I've set it to 100 ohms, 757. So we'll go up. So now we should see, if we go from 757, we go back to temp, so it's displaying it. Put it on the right one. So that's your 10 ohms, that's the minimum setting, and that's full. Missed it. And that's minimum. Now, in between there, we could set, if we go, let's say we put the tank temperature at the point where we want it to be, that's the warning point. In that case, this case, it's 33 ohms, and if we have the system up to temperature and we say, oh, we want that to be the maximum, we can come across here. We leave the endpoints where they are. 0 and 100% are always going to be there. So what we want to do is now say at maximum we want this to be that third tick mark, which is the 75% output. So if we come across here, so the ticks are at 25, 50 and 75. So if I'm stepping that up, and you can see it's going down, so we'll go down. So, okay, if we set it there, we know that's where it's going to be when it hits that 33 ohms, which you could say would correspond to your maximum temperature. If we go that you want the engine to run at, after that you treat it as a warning. So now we go the other way and say, oh, this one. So this is 82 ohms, and we'd say, oh, well, that's where we want it to start reading the normal operating range. So, okay, we come across, and that we want to be the 25% point. So we go to the X and we adjust that up. Alright, so in this case, when it gets to 82 ohms, we're going to indicate that we're 25%, we're up in the operating temperature range. When it gets down to 33 ohms, that's become our warning point. So now if I go to somewhere in the middle, I think that one should be about 56 ohms. That indicates where we are in the operating range, it's 331. So the same system applies for the fuel and the pressure gauges. If I just come down and go temp, you've seen fuel, which way up the sensors are that you want. Fuel and temperature usually decrease in reading as the value increases. The pressure meter will run the other way. It's normal, its voltage goes up with increasing pressure. So you've got the facility to adjust the gauges to the set points you want to match any sensor you've got connected. You've also got some variance in how you can want the gauges to read. But it will normally come with the default types in. The last point on these displays is if we go across to the last column, this shows how the value is sampled and treated. So sometimes you'll have some of the ECUs will output pulse values and you have to average them. There's filtering in the meter and you sort of take an average level, but you might want a peak hold that it decays away. The time is averaged, it's averaged over how long that decay is, or sometimes you want a raw. Usually you'd want, if you've just got a resistive sensor, you'll just average it, and depending on how slow, temperature might be 3 seconds, or 6 seconds probably. Go down, and we'll just put it as 6 seconds for now as examples. The tachos and speedos are always raw. So we hit save, we hit quit, back to configuration. That's it. That's a basic setup. It shows you that you can adjust the angles and the input parameters that are measured to suit your sensors and your meters. That's pretty much enough for now, I would think. Alright, it gives you an idea of what the gauge is capable of. I'll leave it there. See you later.